In question 10, it says that a diagram shows part of the curve y equals to 8 upon x plus 2x and a minimum point m. In the first part, we have to find expressions for dy dx, d square y dx square, and integrate integral of y whole squared. So as we know that y equals to 8 upon x, we'll write it as 8x to the power minus 1 plus 2x. Now finding the dy dx, in the first step, we'll multiply minus 1 by 8, so that will become a minus 8x to the power minus 2, as we decrease the power by 1 when differentiating, plus, so the x power is 1 over here, 1 times 2 will become 2, x to the power 0. So we can write dy dx is minus 8 upon x squared plus 2. Now in the next step, we have to find d square y upon dx square, which means we differentiate dy dx again. So we'll multiply minus 2 by minus 8, that will become a plus 16. We'll decrease the power by 1, which will become a minus 3. And differentiating 2, it will become a 0 as it is a constant. So we can write it as 16 upon x cube. And in the third part, we have to integrate y whole squared. So integrating y squared, first of all, we'll write it as 8 upon x plus 2x whole squared and integral sign. So before integrating, we'll expand this expression. So this will become 64 upon x squared, a square plus 2 times ab. So that will be 8 upon x into 2x, and then plus b squared. So that will be 2x whole squared. Simplifying this before integrating, we'll write it as 64x to the power minus 2. This will cancel out. So this will become a to the 16 times 2, 32 plus 4x squared. Now applying the integration sign all these three terms. So integrating 64x to the power minus 2, we'll increase the power by 1. So this will become minus 2 plus 1. So 64x to the power minus 1. And we divide it by the new power. Plus integrating 32 will make it 32x. And we increase the power by 1 over here. So this will become 4x cubed divided by the new power, which is 4x cube upon 3. So we can write this as minus 64 upon x plus 32x plus 4x cube upon 3. So this was the first part. Now in the second part, it is asking us to find the coordinates of M and determine the nature of the stationary points. Now, as M is a minimum point, it means that dy dx will be equal to 0. So in part 2, we'll put the dy dx that we had in our first part. So dy dx was minus 8 upon x squared plus 2 equals to 0. Taking the LCM, we'll get minus 8 plus 2x squared equals to 0. We'll write it as 2x squared is equals to 8, or x squared is equals to 4. Taking the square root, we'll get the values of x as plus minus 2. Now to find the nature of the stationary points on the part of the curve, so as m is on the positive side, so we'll be taking the value of x as 2. Now to find the nature, we'll substitute this value of x into the double derivative that we found, which was 16 upon x cube. So as we had d square y upon dx squared. So in this part, it is asking us to find the stationary point on the part of the curve for which x is less than 0. So we'll be taking x equals to minus 2. So now using 16 upon x cubed, so substituting minus 2 over here, we'll get 16 upon minus 8. As it is a negative, it means that the nature will be a maximum point. In part 3, we have to find the volume obtained when the region bounded by the curve, the x-axis, and the line x equals to 1 and x equals to 2 is rotated through 360 degrees about the x-axis. So to find the volume, the formula is volume is equals to pi times the integral of square of the function y. Now, we had already found that y squared integral was minus 64 upon x plus 32x plus 4x cube upon 3. We just have to apply the limits 2 and 1. So applying the limits 2 and 1 to minus 64 upon x. So in place of x, first we'll put the upper limit, which is 2 plus 32 times 2 plus 4 into 2 cube upon 3. And subtracting the lower limit, we'll get minus 64 upon 1 plus 32 times 1 plus 4 into 1 cube upon 3. Substituting this value in our calculators, it will simplify down to 220 upon 3, and we'll add pi to the final answer. So the final volume will be 220 pi upon 3.